Hello and welcome. Tonight, we'll be exploring how small we really are in the universe. For most of your life, the Earth probably feels enormous. You can spend hours traveling across a city and still feel as though you have barely gone anywhere. You can look at a map and see countries stretching across oceans, mountain ranges crossing continents, and roads winding toward places you may never visit. The world seems vast because, for a human being, it is vast. And yet, if you could slowly rise above it, farther and farther into the darkness of space, something remarkable would begin to happen. The cities would disappear first, then the roads, then the borders between countries. The great rivers and mountains would become difficult to see. Eventually, even the continents would begin to fade into the blue and white surface of a small planet floating in darkness. And all the places that once seemed so large would be gathered together into a single world. Your world. The world where every human life you have ever known has unfolded. Every conversation, every morning, every childhood, every invention, every war, and every moment of peace. Every person who ever looked up at the night sky and wondered what might be beyond it. All of it has happened here, on Earth. From the surface, Earth can feel like the center of everything. It is the ground beneath your feet. It is the air entering your lungs. It is the place where the sun rises in the morning and disappears again at night. But the universe does not share our sense of scale. The universe has no special reason to consider a city large simply because millions of people live there. It has no reason to consider a continent large because it takes days to cross. And it has no reason to consider Earth large because an entire species has built its history upon it. From a cosmic distance, Earth is simply a small planet moving through space. That realization can sound strangely uncomfortable at first, but there is something peaceful about it too, because the things that separate us from one another often become very small when seen from far enough away. From orbit, there are no visible borders painted across the oceans. No line tells you where one country ends and another begins. The atmosphere wraps around the entire planet as one thin layer. The same sunlight falls across different continents. The same clouds drift above millions of people who may never meet. And from far enough away, Earth begins to look less like a collection of separate nations and more like one small home, one world, one place. In the late 20th century, the Voyager spacecraft carried cameras far beyond the familiar worlds of the outer solar system, and from an extraordinary distance, one of those cameras turned back toward home. The resulting image showed Earth as a tiny point of light suspended in the darkness. It became known as the pale blue dot. The image is powerful not because Earth disappears completely. It is powerful because Earth is still there, tiny, delicate, almost lost among the enormous darkness surrounding it. And yet that tiny point contains everything we know about human history. The first people who watched fire flicker in the night, the first stories told beneath ancient skies, the first cities, the first ships crossing oceans, the first telescopes turned toward distant worlds, and eventually, people who built machines capable of traveling far enough away to photograph their own planet as a speck. There is a strange symmetry in that. We left Earth so that we could see Earth, and when we finally looked back, we discovered just how small our home really was. But perhaps the most difficult part of understanding cosmic scale is not the size of the universe. It is the weakness of our intuition. Your mind evolved to navigate distances that matter in everyday life. A few steps, a road, a mountain, a journey across a city. Even the distance from one side of Earth to the other is already difficult to imagine as a physical distance. Astronomical distances are something else entirely. They are so large that ordinary units begin to lose their meaning. Kilometers become difficult to picture. Millions of kilometers become abstract. And eventually, astronomers use light years, a way of describing the enormous distance that light travels in 1 year. Light moves so quickly that, in everyday life, it seems almost instantaneous. But space is so large that even light needs time to cross it. This gives us one of the quietest and most beautiful ideas in astronomy. When you look into space, you are not simply looking far away, you are looking into the past. The light from the sun takes a little more than 8 minutes to reach Earth. So when you see sunlight, you are seeing the sun as it was a little more than 8 minutes earlier. The moon is also seen slightly in the past. The planets are seen farther into their past, and distant stars are seen as they were years, centuries, or thousands of years ago. The farther away we look, the farther back in time we see. Space becomes a kind of natural memory, and Earth, despite being our entire world, occupies only the smallest part of that enormous landscape. Still, being small is not the same thing as being unimportant. A grain of sand is small, a snowflake is small, a single breath is small. But size alone does not tell us what something means. The Earth may be only a tiny world in a vast universe, yet it is a world with oceans, forests, storms, mountains, living cells, music, memory, and minds, capable of wondering about the stars. And perhaps that is where our journey should begin, not by asking whether the universe is too large for us, but by asking how far away the first familiar object in the sky really is. The moon has followed Earth for billions of years. It looks close enough to touch. It rises above familiar rooftops. It hangs over quiet oceans, and from the ground it seems almost like a companion sitting just beyond the atmosphere. But when we begin to measure the space between Earth and the moon, our ordinary sense of distance starts to break apart. The moon is much farther away than it looks. And the emptiness between these two worlds will be our first real glimpse of how enormous space truly is. For a moment then, let Earth remain beneath you. A small blue world, a quiet island of life. And somewhere beyond it, suspended in the darkness, the moon waits. Not quite as close as it appears, and not nearly as close as our minds would like to imagine. Look up at the moon, if you can picture it tonight. Perhaps you have seen it so many times that it hardly seems remarkable anymore. It may be a thin silver crescent above a rooftop. It may be a pale circle hanging between clouds. Or perhaps it is hidden tonight, somewhere beyond the horizon, continuing its quiet journey around Earth whether we are watching or not. The moon feels close. It feels like part of our neighborhood. We can point toward it with one hand. We can photograph it with a camera. We can watch its surface change from night to night. And because it appears so clearly above us, the mind naturally treats it as something nearby. But the sky is very good at hiding distance. The moon is not sitting just above the clouds. It is not hovering a few kilometers above the atmosphere. Between Earth and the moon lies an enormous stretch of space. And one of the simplest ways to feel that distance is to shrink the Earth down to something you can hold in your hands. Imagine that our planet has been reduced until it is about the size of a basketball. You could place this small Earth on a table. You might even imagine the continents painted onto its surface, tiny oceans covering the familiar blue and green globe. Now imagine the moon reduced by exactly the same scale. You might expect it to sit only a short distance away, perhaps just beside the basketball, but it would not. The moon would be several meters away. The exact image is less important than the feeling it creates. Earth would be small enough to hold, the moon would still be small, and yet there would be a surprisingly large empty space between them. That empty space is the first clue. When we look at photographs or diagrams of the Earth and moon, the two worlds often appear much closer together than they really are. This is understandable. If a picture showed the true distance while keeping Earth and the moon at their true relative sizes, the image would become difficult to appreciate. The two worlds would occupy only tiny parts of the frame. Most of what you would see would simply be darkness, nothing, empty space. This is one of the quiet secrets of astronomy. Space looks crowded when we draw it, but reality is much emptier. The planets are not arranged like rooms in a house, one beside another. They are separated by enormous distances. And the farther we travel from Earth, the more obvious this becomes. Even reaching the Moon, which has always seemed like the nearest great destination in the heavens, means crossing a vast region of space. Human beings have done it. Machines have done it. And yet, on the scale of the solar system, the Moon is still very close to home. It is our first neighborhood beyond Earth, the first small step into a much larger landscape. You might imagine standing on the Moon and looking back toward Earth. Our planet would appear as a bright world hanging in the black sky, and from there you would realize something strange. You have traveled hundreds of thousands of kilometers. You have left Earth behind. You have crossed the boundary of the atmosphere and stood on another world. And still, in the enormous architecture of the solar system, you have barely begun. The Sun is still much farther away. The planets stretch outward through immense darkness, and beyond them lie distances so large that ordinary maps stop being useful. This is why astronomers need different ways to describe distance. One of the most useful is the light year. Despite its name, a light year is not a measure of time. It is a measure of distance. It describes how far light can travel in 1 year, and light travels extraordinarily fast. In the time it takes you to blink, light can cross distances that would take our fastest spacecraft far longer. Yet even light needs time when the distances become astronomical. The sunlight reaching your face has traveled from the Sun for a little more than 8 minutes. So when you look toward the Sun, you are never seeing the Sun exactly as it is at that moment. You are seeing the Sun as it was a little more than 8 minutes earlier. That difference is tiny in everyday life. 8 minutes is hardly enough time to prepare a cup of tea. But across the universe, these delays become much larger. The light from the Moon reaches us after a little more than a second. The light from the planets takes longer. The light from nearby stars can take years. And the light from distant galaxies may have been traveling for millions or even billions of years before reaching the instruments we build here on Earth. So space is not simply a place, it is also a record of time. The farther away you look, the older the light becomes. Every distant star is carrying an older version of itself toward you, and every telescope is, in a sense, looking through layers of cosmic history. But before we travel that far, it is worth pausing here, between Earth and the Moon, because this small distance already teaches us something profound. Our minds are not naturally built to imagine astronomical space. We evolved to judge distances across forests, plains, rivers, and landscapes. We know what a kilometer feels like when we walk. We know what an hour feels like when we travel. But millions of kilometers have no natural sensation attached to them. They are numbers without familiar texture. That is why comparisons matter. A basketball, a few meters of empty space, a beam of sunlight traveling for more than 8 minutes. These simple images give the mind somewhere to stand. And once the Moon has shown us how deceptive distance can be, we can begin to look toward the next great object in our sky, the Sun. It appears as a small glowing disk, something you can cover with a fingertip when you hold your hand at the right distance. But that tiny disk is actually a star, vastly larger than Earth. It contains almost all of the mass in the solar system, and its gravity quietly shapes the paths of the worlds that surround it. The Moon taught us that nearby does not mean close. The Sun will teach us something even stranger. Something can look small and still be unimaginably large. The Sun is one of those things you see so often that it can become almost invisible to your attention. It rises, it crosses the sky, it warms the pavement beneath your feet, it slips behind the horizon, and tomorrow it returns. Because this rhythm is so familiar, it is easy to forget what the Sun actually is. It is not a lamp hanging above Earth. It is not a small glowing object sitting nearby. The Sun is a star. and compared with Earth, it is enormous. If you could place Earth beside the Sun, our planet would seem almost delicate. The Sun is more than 100 times wider than Earth. Its volume is so great that more than 1,000,000 Earths could fit inside it, if you could somehow arrange them without leaving empty spaces between them. But perhaps even that comparison is difficult to feel. So imagine something simpler. Imagine shrinking the entire solar system until the Earth becomes a tiny marble. The Sun would no longer feel like another object sitting nearby. It would become the great center of the miniature landscape. The planets would move around it at different distances, like small travelers crossing an enormous open field, and between them, there would be almost nothing. The Sun dominates this landscape because of gravity. Gravity is invisible. You cannot see it stretching through space. You cannot hold it in your hands. But its influence reaches across the solar system, shaping the paths of planets, asteroids, comets, and countless smaller objects. Earth does not orbit the Sun because something is physically holding it on a track. Instead, Earth is moving through space, while the Sun's gravity continually bends that motion into an orbit. It is a little like throwing a ball forward, while gravity pulls it downward. Only here, the motion is happening on a much larger scale. Earth is constantly falling toward the Sun, while also moving sideways quickly enough that it keeps missing it. And so the planet continues along its great path around the star. Year after year, century after century, the Sun and Earth have been performing this quiet dance for billions of years. And all the while, sunlight has been crossing the space between them. Light from the Sun takes a little more than 8 minutes to reach Earth. That means the sunlight touching your face is already more than 8 minutes old. If the Sun suddenly changed in some dramatic way, we would not know immediately. For a little while, the sunlight arriving here would continue as though nothing had happened. The light simply needs time to cross the distance. 8 minutes may not sound like much. You might spend 8 minutes waiting for water to boil. You might spend 8 minutes listening to a song. You might spend 8 minutes looking out of a window before going to sleep. But that small delay reveals something important. Even the Sun, the nearest star to Earth, is not actually seen in the present moment. We see it slightly in the past. And the farther we look into space, the deeper into the past we see. The Sun is also the reason Earth is not simply a cold rock drifting through darkness. Deep inside the Sun is an extraordinary environment. The temperature and pressure are so intense that hydrogen can be transformed through nuclear fusion, releasing enormous amounts of energy. That energy begins its long journey outward from the Sun. Eventually, some of it reaches Earth as light and heat. Plants capture a portion of that energy. Oceans and atmosphere respond to it. Weather is influenced by it. The climate system depends upon it. And life, directly or indirectly, is powered by the energy of this distant star. Every leaf reaching towards sunlight is participating in an ancient relationship between a planet and its star. Every warm afternoon carries a little piece of the Sun's energy. Even the food you eat can be traced, in one way or another, back to sunlight. The Sun therefore feels enormous, not only because of its physical size. It is enormous because of what it does. It gives the solar system its dominant source of energy. It provides the light by which we see our world. And its gravity gives the planets their great orbital paths. Yet Earth cannot simply be anywhere around the Sun and remain the world we know. The relationship between our planet and its star is delicate. Earth receives enough energy for water to remain abundant on the surface, while its atmosphere helps regulate temperature and protect the environment where life developed. Distance matters. Atmosphere matters. Chemistry matters. The history of the planet matters. Life exists within a complicated balance of conditions, and this balance will not last forever. The Sun is a star with a long life ahead of it, but it is not eternal. Stars change. The Sun is currently in a relatively stable stage of its life, steadily converting hydrogen into helium in its core. But eventually, billions of years from now, the hydrogen in its core will become depleted. The Sun will change. It will expand dramatically and enter a red giant phase. The quiet yellow-white star that has illuminated Earth for so long will become a very different kind of object. For us, this is unimaginably far in the future. There is no need to worry about it tonight. The important thing is simply to notice the scale of time. The Sun has been shining for billions of years. Human civilization has existed for only a tiny fraction of that history. And an individual human life is smaller still. You can almost feel the layers of scale beginning to stack on top of one another. A human lifetime, human civilization, Earth, the age of the Sun, the age of the solar system, and beyond that, the age of the universe itself. Yet there is something comforting about this vastness. The Sun does not need us to be large, it simply shines. Earth does not need to be the biggest planet. It simply carries oceans and forests and living things. And we do not need to occupy a large portion of the universe for our existence to matter. For now, Earth travels quietly around the Sun. The Moon follows Earth. The Sun moves through the Milky Way. And all around them, enormous distances separate one world from another. The planets that seem so close together in textbooks are actually scattered across a vast, dark landscape. If we could remove the labels from a solar system diagram and replace the neat little drawing with reality, something surprising would remain. Not a crowded family of planets, but mostly darkness, mostly distance, mostly empty space. And as we begin to travel outward from the warmth of the Sun, that emptiness will become harder and harder to ignore. If you could somehow remove the darkness from space and make every planet visible at once, the solar system might look like a busy neighborhood. You would see Mercury close to the Sun, then Venus, then Earth and the Moon. Farther out, Mars. Beyond it, the enormous presence of Jupiter, then Saturn with its beautiful rings, and farther still, Uranus and Neptune. On a page, it looks almost orderly, almost crowded, but the real solar system would look very different. The planets would be separated by enormous stretches of darkness. If you stood beside the Sun and looked toward Earth, you would not see our planet hanging nearby like a decoration. You would see almost nothing, and that almost nothing is the true scale of our planetary neighborhood. The planets are islands. The space between them is the ocean. As you move outward from the Sun, the distances become larger and larger. A spacecraft, traveling from one world to another, cannot simply cross a short gap. It must spend months or years moving through an environment that is almost completely empty. There are no roads, no signs, no convenient resting places, only sunlight, radiation, dust, small particles, and an immense amount of darkness. This is one reason space exploration is so difficult. The challenge is not simply reaching another planet, it is crossing the enormous distance between one destination and the next. And perhaps the first world that truly makes this scale visible is Jupiter. Jupiter is enormous. It is more than 11 times wider than Earth, and its mass is more than 300 times greater than that of our planet. But numbers alone do not quite capture its presence. Imagine Earth as a small ball. Now place Jupiter beside it. Our planet begins to look almost like a small companion beside a giant. Jupiter is the largest planet in the solar system. Its immense gravity reaches far into the surrounding space, influencing the paths of comets, asteroids, and other small objects. Some objects passing through the solar system can have their paths dramatically changed by Jupiter's gravitational pull. In this way, Jupiter acts as one of the great gravitational sculptors of our planetary neighborhood. But Jupiter is not simply a giant ball of gas sitting quietly in space. Its atmosphere is restless. Bands of clouds circle the planet. storms can persist for years, and among them is the Great Red Spot, a gigantic storm system that has been observed for centuries. When you look at Jupiter through a telescope, it can seem beautiful and almost peaceful. Soft bands of cream and brown, a pale sphere hanging against blackness. Yet beneath that appearance is a world of enormous pressures, powerful winds, and violent atmospheric motion. And then there is Europa. From a distance, Europa looks like a small icy moon. Its surface is covered in frozen material, crossed by long fractures and lines. But beneath that frozen exterior, scientists have strong evidence for a vast ocean of liquid water. We should be careful here. An ocean does not automatically mean life. Europa has not been shown to contain living organisms. But the possibility of liquid water beneath an icy surface makes this distant moon one of the most fascinating places to study when we ask where environments suitable for life might exist beyond Earth. And Jupiter is only one of the worlds along our outward journey. Farther away, another planet begins to appear, Saturn. If Jupiter teaches us about size and gravity, Saturn teaches us something different. It teaches us that even in an enormous and mostly empty universe, beauty can emerge from astonishingly simple pieces. Saturn's rings look like a single solid structure when viewed from far away, but they are not. They are made of countless individual pieces of ice and rocky material. Some are tiny, some are much larger. Together, they form the magnificent bands that surround the planet. From Earth, the rings can look almost delicate, but they exist in an environment of powerful gravity, extreme winds, and enormous atmospheric storms. Saturn itself is a giant world, more than 9 times wider than Earth, and yet the rings can make the planet feel almost dreamlike. A vast planet floating in darkness, surrounded by countless fragments of ancient material. The farther we travel, the more the solar system begins to feel less like a collection of familiar worlds and more like an enormous museum of strange environments. Saturn has another remarkable world nearby, Titan. Titan is larger than the planet Mercury and has a thick atmosphere. But what makes it especially unusual is the behavior of liquids on its surface. On Earth, water flows through rivers. Water fills lakes. Water falls from clouds as rain. On Titan, the surface is so cold that methane can exist as a liquid. Methane can fall from the sky, it can flow across the surface, and it can collect in lakes and seas. So Titan has something that looks strangely familiar and yet completely alien. Rivers, rain, lakes. But they are made from substances behaving in a world far colder than our own. It is almost as if the solar system has taken familiar pieces of Earth and rearranged them under completely different rules. And this is one of the quiet surprises of exploring space. The farther we travel, the less the universe resembles the simple pictures we carry in our minds. A planet is not simply a colored ball. A ring is not a solid circle. A moon is not necessarily a barren rock. And the solar system is not a neat row of worlds separated by convenient distances. It is a vast region of almost unimaginable emptiness, containing small pockets of matter, energy, motion, and complexity. Even Jupiter, the giant of the planets, occupies only a tiny part of the space around the Sun. Even Saturn and its magnificent rings are surrounded by darkness. And beyond Saturn, the distances grow greater still. Uranus waits in the cold outer reaches. Neptune lies farther away. Beyond Neptune, Pluto travels through an ancient region of ice and rock. And beyond even that, the familiar idea of where the solar system ends begins to become uncertain. The farther we go, the less there is to see. The sun becomes smaller. The planets become more widely separated. The darkness grows. And somewhere ahead are worlds where a human lifetime can pass before a planet completes a single journey around the sun. The solar system is beginning to reveal its true character, not as a crowded family of planets, but as a vast, quiet ocean of space, with worlds scattered through it like distant islands. The farther we travel from the Sun, the quieter the solar system becomes. The familiar warmth of the inner planets is now far behind us. The Sun is still there, still shining, still holding the planets in its enormous gravitational embrace. But from these distant worlds, it would look very different. The great golden disk that dominates our sky from Earth would have become much smaller, and the darkness surrounding it would seem much larger. One of the first worlds we encounter is Uranus. Uranus is unusual even among the strange worlds of the outer solar system. Its axis is tilted by roughly 98 degrees. In a simple picture, you can imagine the planet almost rolling around the Sun on its side. It is an extraordinary orientation, and because of that tilt, Uranus experiences seasons unlike anything we experience on Earth. One hemisphere can spend years receiving prolonged sunlight, while the other experiences a long period of darkness. A year on Uranus lasts more than 80 Earth years. Imagine being born on Uranus and watching the seasons change. A human lifetime would barely cover one complete journey around the Sun. The seasons there move on a timescale that feels almost geological compared with our familiar calendar. And yet Uranus is not the farthest major planet. Beyond it lies Neptune. Neptune is so distant from the Sun that sunlight takes hours to reach it. By the time that faint light arrives, it has already crossed an enormous region of space. And yet Neptune is far from a quiet, frozen marble. Its atmosphere contains some of the fastest winds known on any planet in the solar system. The world appears deep blue and calm from a distance. But beneath that beautiful color, the atmosphere is moving with tremendous speed. Neptune also has an extraordinarily long year. One trip around the Sun takes more than 160 Earth years. A person could be born, grow old, and pass away without seeing Neptune complete a single orbit. This is one of the strange things about planetary time. We often think of a year as a natural unit, one revolution, 12 months, 4 seasons. But a year is only a measure of one world's journey around its star. Change the world, and the meaning of a year changes with it. Then, farther out still, we reach Pluto. For much of modern history, Pluto was introduced to generations of children as the 9th planet. It occupied a special place in our imagination, the distant little world at the edge of the solar system. But as astronomers discovered more objects beyond Neptune, the picture became more complicated. Pluto was found to be part of a larger population of icy worlds. Scientists eventually created a different category for these objects. Pluto became known as a dwarf planet. But the change in classification did not make Pluto less interesting. Quite the opposite. When the New Horizons spacecraft finally reached Pluto in 2015, humanity received its first close look at this distant world. And Pluto was not the simple frozen rock that many people had imagined. Its surface contained mountains, broad plains, layers of ice, a thin atmosphere, and landscapes far more complex than expected. One of the most striking discoveries was a vast, bright region shaped somewhat like a heart. It was a reminder that even a tiny, distant world can contain a history written into its surface. Pluto had been waiting in the darkness for billions of years, and for the first time, a small machine from Earth had arrived to look closely. Beyond Pluto lies the Kuiper Belt. Rather than being a sharp boundary, it is more like a broad, cold region populated by many icy bodies. These objects are leftovers from the early construction of the solar system. Some are small, some are worlds in their own right. Together, they form something like an ancient archive. They preserve material from a time when the planets were still forming. And this changes the way we imagine the edge of our planetary system. There is no simple fence, no cosmic wall, no sign saying that the solar system ends here. Instead, the transition becomes gradual. The familiar planets give way to smaller icy bodies. Those bodies become more widely separated. The influence of the Sun continues farther outward, and eventually, we reach an even more distant region that astronomers believe may surround the solar system, the Oort Cloud. Unlike the planets and moons we can observe directly, the Oort Cloud has never been photographed. No spacecraft has traveled there. Scientists infer its existence from the behavior of long-period comets, whose enormous orbits suggest that many of them may originate in a distant, roughly spherical reservoir surrounding the solar system. It may extend vastly farther than the region containing the known planets. And because it is so distant, the boundary of our solar system becomes almost philosophical. Where does the solar system actually end? At the orbit of Neptune? At the Kuiper Belt? At the outer influence of the Sun? Or somewhere in the distant region where comets slowly wait for gravity to disturb their ancient paths? There is no single simple answer. The solar system does not have a physical wall separating home from outside. Its influence gradually fades into the surrounding interstellar environment. And that is fitting, because nature rarely follows the neat boundaries we draw on maps. We draw borders because they help us organize ideas. But the universe is under no obligation to organize itself for our convenience. As we move outward, the Sun continues to grow smaller in our imagined sky. Planets become distant memories. The beautiful rings of Saturn are far behind. Jupiter, once the giant of our planetary neighborhood, is now only another distant world. Even Pluto, which once seemed to mark the very edge of everything familiar, is no longer an endpoint. There is more, far more. And somewhere beyond these distant icy regions, the Sun's gravitational influence becomes increasingly faint. The solar system begins to merge gradually into the space between stars. For the first time, our planetary home begins to feel less like an entire universe, and more like one small neighborhood inside something much larger. Yet humanity has not simply watched this journey from Earth. We have sent two tiny machines outward. They were launched in the year 1977, and they have continued traveling long after their original planetary encounters were complete. They are called Voyager. Their journey will give us another way to understand just how enormous the space between worlds really is. Because even after decades of travel, they have only begun to cross the cosmic distance separating our home from the stars. For a moment, imagine that you are standing at the edge of the solar system. Behind you are the worlds we have just passed. The blue Earth, the Moon, the bright Sun, Jupiter and its enormous storms, Saturn and its rings, the distant blue worlds of Uranus and Neptune, and far behind them, Pluto moving quietly through the cold. Ahead of you, there is no road, no destination that can be seen with the naked eye. Only darkness. The sun is still shining behind you, but it has become a much smaller presence. And somewhere in that darkness, two small machines are continuing a journey that began almost half a century ago. They are Voyager 1 and Voyager 2. Both spacecraft were launched in 1977. At the beginning of their missions, they were sent toward the outer planets. They flew past Jupiter. They visited Saturn. Voyager 2 continued onward to Uranus and Neptune, becoming the only spacecraft ever to make close encounters with all four giant planets. But their journeys did not end there. After completing their planetary encounters, the spacecraft continued outward, year after year, decade after decade. They kept moving through the darkness. There is something almost poetic about that. The machines are small, the universe is enormous, and yet the machines continue. They carry with them one of the strangest objects humanity has ever sent into space, the Golden Record, a message attached to a spacecraft traveling into the unknown. It contains sounds from Earth, greetings in many human languages, music, images, and recordings intended to offer a small impression of what our world is like. It is not a practical message in the ordinary sense. No one knows whether another civilization will ever find it. There is no guarantee that anyone will ever listen. The spacecraft may travel through interstellar space for an unimaginably long time without meeting another intelligent being. And still, we sent the message, perhaps because humans have always had a habit of leaving traces behind. We write names in books, we carve words into stone, we take photographs, we build monuments, and sometimes, when we look beyond our own world, we send a small record of ourselves into the darkness. The golden record is something like that, a quiet hello from one tiny planet. But Voyager also reveals something less poetic and much more difficult: distance. Even after decades of travel, the spacecraft have crossed only a tiny part of the space between stars. This can be difficult to understand because Voyager has traveled extraordinarily far by human standards. It has traveled farther than any human-made object. It has entered the region where the sun's influence gradually gives way to the surrounding interstellar environment. And yet, compared with the distance to even the nearest other star system, Voyager's journey is remarkably small. The nearest stellar system to our own is the Alpha Centauri system, a little more than 4 light-years away. That phrase can sound deceptively simple, 4 years, but remember what a light-year means. It is not the time a spacecraft needs to travel. It is the distance that light itself travels in 1 year. And light moves through space at an astonishing speed. So when astronomers say that another star is more than 4 light-years away, they are describing an enormous gulf. A gulf that even our fastest spacecraft cannot simply cross in a few years. The difference becomes easier to imagine if we return to the idea of scale models. Suppose the Sun were reduced to the size of a small marble. Earth would become a tiny speck orbiting nearby. The outer planets would spread farther into the darkness. The Kuiper Belt would extend farther still. And then, after all those enormous distances, the nearest star would still be much farther away. There would be a huge region containing almost nothing between one stellar neighborhood and the next. This is perhaps the greatest surprise of interstellar space. It is not crowded. There are no planets waiting every few kilometers. There are no bright stars scattered conveniently along the route. The universe may contain an enormous number of stars, but those stars are separated by enormous distances. A spacecraft can travel for decades and still find itself surrounded mostly by darkness. And this is why reaching another star is such a profound challenge. The problem is not simply building a vehicle that can move quickly. It is surviving the journey. It is carrying enough energy. It is navigating accurately. It is communicating across immense distances. And, perhaps most importantly, it is accepting that a journey between stars may take far longer than a human lifetime. Imagine leaving Earth knowing that you may never see another world. Imagine traveling through darkness while the sun becomes smaller behind you. Imagine that the people who launched your spacecraft are gone, and perhaps the people who designed its instruments are gone too. The machine continues anyway. It becomes a traveler across generations. Voyager therefore represents something larger than engineering. It represents patience. A human civilization can create something that continues moving long after the people who built it have disappeared. And there is another beautiful detail. The spacecraft do not travel toward some known destination. They are simply continuing outward. There is no final planet waiting for them. No cosmic harbor. Their journey is defined by motion itself. Eventually, they will become colder and quieter. Their instruments will no longer be able to communicate. Their signals will fade. But the spacecraft themselves may continue drifting through interstellar space, perhaps for an extraordinarily long time. And if you imagine that scene from very far away, Voyager begins to look almost impossibly small. A little machine, a faint signal, a tiny human message. moving through an ocean so large that the solar system itself becomes difficult to distinguish within it. And behind Voyager, our entire planetary home continues its quiet journey around the Milky Way. The Earth is still there, the sun is still shining, the planets are still moving, and beyond the outer darkness of the solar system, the stars are waiting, not close together, not arranged like lights along a road, but scattered across an enormous black expanse. The journey outward has reached a new kind of distance. We have crossed from the scale of planets to the scale of stars, and suddenly, even our enormous solar system begins to look very small. For a while, it may be useful to imagine that the solar system is everything: the sun at the center, the planets moving around it, the distant icy worlds, the Kuiper Belt, the enormous region where the influence of the sun gradually becomes weaker. It is already difficult to imagine something larger. But the solar system is not a universe. It is not even a galaxy. It is one small neighborhood inside a much larger city of stars, the Milky Way. When you look into a clear night sky, many of the stars you can see belong to our own galaxy. They may appear to be scattered randomly across the darkness, but they are not isolated lights floating independently through an empty universe. They are part of an enormous structure. The Milky Way is a galaxy containing hundreds of billions of stars, and our sun is only one of them. That idea can take a little time to settle into the mind, because from Earth, the sun feels extraordinary. It rises every morning. It provides almost all of the energy that powers the surface environment of our planet. Without it, our world would be profoundly different. From Earth, the sun seems central to everything. But from the perspective of the Milky Way, it is an ordinary star, not the largest, not the brightest, not at the center, just one star among an enormous population, and our solar system occupies only a tiny region around it. The Milky Way itself is a spiral galaxy. If you could somehow rise far above it and look down, you would see enormous arms of stars, gas, and dust curving around a brighter central region. But we cannot simply fly outside the Milky Way and look back at it. We live inside it. Our position is somewhere in one of the galaxy's spiral arms, far from the galactic center. So when you look upward at night, you are looking through the galaxy from within. The faint band of light that stretches across a dark sky is the combined glow of countless distant stars. It is our galaxy seen from the inside. There is something strangely intimate about that. We are not visitors standing outside the Milky Way. We are part of it. The atoms in your body are here. The Earth is here. The sun is here. And all of it is moving together through the enormous structure of the galaxy. Our cosmic address can therefore become a little longer. You are on Earth. Earth is in the solar system. The solar system is inside the Milky Way. And the Milky Way is not alone. Our galaxy belongs to a collection of galaxies called the Local Group. Among its larger members are the Milky Way and the Andromeda Galaxy, along with many smaller galaxies. These galaxies are bound together by gravity. They move through space together as part of a much larger neighborhood. And once again, something that seemed enormous becomes only one layer in a much larger structure. It is almost like standing inside a house and slowly discovering that the house belongs to a neighborhood, the neighborhood belongs to a city, and the city belongs to a landscape far larger than anything you can see from your window. Except the cosmic version has no streets, no buildings, no signs, only gravity and immense stretches of space. The Milky Way itself is moving. The solar system is moving around the center of the galaxy. The galaxy is moving relative to other galaxies, and those galaxies participate in even larger patterns of motion. So even when you are lying perfectly still in bed, you are not actually motionless. Earth is rotating beneath you. Earth is traveling around the sun. The sun is moving through the Milky Way, and the Milky Way is participating in the motion of the larger cosmic environment around it. You may feel completely still. But the universe does not share that feeling. Everything is moving, quietly, continuously, and now the scale becomes even stranger. When astronomers map the universe on the largest scales, galaxies do not appear to be spread evenly like grains of sand across a flat surface. Instead, they form enormous patterns. Galaxies gather into groups and clusters. Those structures connect through vast filaments, and between them are enormous regions containing comparatively few galaxies. These regions are called cosmic voids. The name sounds almost empty enough already, and in a sense, that is exactly the point. The universe contains places where matter is much more concentrated and places where it is extraordinarily sparse. On the largest scales, the universe resembles something like a vast web. Long strands of galaxies stretch across space. Dense knots gather where enormous numbers of galaxies reside. And between these structures lie great dark spaces, the cosmic web. It is difficult to imagine because there is nothing in everyday life quite like it. But perhaps you can picture a very faint, three-dimensional network extending across unimaginable distances. The bright parts are not individual stars, they are galaxies. And each galaxy contains enormous numbers of stars. So when you step back to this scale, the Milky Way itself becomes just one tiny point within one filament of a structure much larger than the galaxy. This is where the idea of cosmic scale begins to change character. At first, we were comparing Earth with the Moon, then Earth with the Sun, then the planets with the solar system, then the solar system with the distance between stars. Now even the Milky Way is no longer the whole picture. It is one galaxy among countless others, and this is where human intuition reaches one of its deepest limits. We can understand the words. We can understand the measurements. We can build telescopes that observe distant galaxies. We can create maps of enormous cosmic structures. But understanding the information intellectually is not the same as being able to feel the scale. Your mind can say hundreds of billions of stars. It can say millions of light years. It can say cosmic web. But there may be no everyday experience that corresponds to these ideas. So perhaps the best way to approach them is not to force ourselves to imagine every kilometer. Instead, we can simply notice the pattern. Every time we step backward, our previous sense of size becomes smaller. Earth seemed enormous. Then the Moon revealed the distance around us. The Sun revealed the scale of the solar system. The outer planets revealed the emptiness beyond. Voyager revealed the enormous distance between stars. And now the Milky Way reveals that even our entire stellar neighborhood is only one small structure within a much larger universe. Yet there is something beautiful about this continuous widening, because the farther we travel outward, the more connected everything becomes. Earth is part of the solar system. The solar system is part of the Milky Way. The Milky Way belongs to the local group. The local group exists within a much larger cosmic environment, and all of it shares the same universe. There is no separate universe reserved for Earth, no separate sky above one country, no separate space surrounding one star. There is only this enormous connected structure, and somewhere within it, on a small planet circling an ordinary star, a human being can lie quietly at night and wonder how large it all is. Perhaps that is one of the strangest things about being alive. The universe is large enough to make our planet seem almost invisible. And yet, on that almost invisible planet, there are creatures capable of noticing, capable of looking upward, capable of measuring the light from distant galaxies, capable of reconstructing cosmic history, and capable of asking where they belong. Our cosmic address has become almost impossibly long. Earth, solar system, Milky Way, local group, cosmic web. And still, this is not the end of the journey, because beyond galaxies and filaments lies an even larger question. How much of the universe can we actually see? And when we look toward the farthest light reaching Earth, what exactly are we seeing? The answer will take us beyond the Milky Way itself, toward the observable universe. We have traveled a very long way from the ground beneath your feet. We began with Earth. Then the moon showed us that even our nearest neighboring world is separated from us by a surprisingly large distance. The sun revealed a scale far beyond Earth. The planets showed us that the solar system is mostly empty space. Jupiter and Saturn became distant landmarks. Uranus, Neptune and Pluto carried us toward the cold outer regions of our planetary home. Voyager carried our imagination beyond the familiar planets and toward the space between stars. And then the Milky Way appeared. Hundreds of billions of stars. A galaxy so large that even light needs roughly 100,000 years to cross it. Yet the Milky Way itself is only one galaxy, one structure, one small part of a much larger universe. And now, there is one final step outward. What happens when we look beyond galaxies themselves? When we ask how large the universe we can observe actually is, the answer begins with a deceptively simple idea. Light takes time to travel. You already know this from the sun. The sunlight reaching Earth is more than 8 minutes old. If you look at a star 4 light years away, you are seeing that star as it was roughly 4 years ago. If you look at a galaxy millions of light years away, you are seeing light that began its journey millions of years ago. And if you look at galaxies billions of light years away, you are looking at a universe that existed billions of years in the past. A telescope is therefore more than a machine for seeing distant objects. It is also a machine for looking backward through time. The deeper we look, the earlier the universe appears. Eventually, we reach a remarkable limit. There is ancient light surrounding us in every direction. It is called the cosmic microwave background. The name sounds technical, but the basic idea is surprisingly simple. It is faint leftover radiation from the very early universe, a kind of afterglow, a whisper from a time when the universe was much younger, hotter, and denser than it is today. That ancient light has been traveling for billions of years, and today, sensitive instruments can detect it. It is one of the clearest reminders that the universe has a history. It was not always filled with mature galaxies and beautiful spiral structures. There was a time before the stars existed, before galaxies formed, before planets, before Earth, before life. The universe changed, and over enormous stretches of time, gravity helped small differences in the early distribution of matter grow into larger structures. Those structures eventually became the galaxies, clusters, and enormous cosmic filaments we see today. This gives us another extraordinary reversal of scale. The largest structures in the universe did not appear fully formed. They developed gradually from much smaller irregularities in the early universe. Tiny differences became the seeds of enormous cosmic structure. Something small helped create something unimaginably large, and in a quiet way that mirrors the entire journey we have taken tonight. We began with something small, Earth. Then we discovered that Earth belongs to something larger, the solar system. Then something larger still, the Milky Way. Then a cosmic network containing enormous numbers of galaxies. And finally, the observable universe. But there is an important word in that phrase, observable. We often speak about the universe as though we know its complete size, but science is more careful. There is a difference between the entire universe and the part of the universe whose light has had enough time to reach us. The observable universe is the region from which information has been able to reach Earth since the universe became transparent to light. Because space itself has expanded while that ancient light has been traveling, the present-day distance to the farthest observable regions is much larger than simply multiplying the age of the universe by the speed of light. This is one of those ideas that is difficult to picture. You do not need to calculate it. You only need to imagine space itself stretching while light travels through it. The observable universe is roughly 93 billion light-years across. That number is so large that the human mind cannot really visualize it. And perhaps it does not need to. Instead, imagine standing on Earth and looking in every direction. Everywhere you look, there are layers of history. Nearby stars show us relatively recent light. Distant galaxies show us older light. The farthest observable light shows us a much younger universe. It is almost as though the sky contains a series of ancient photographs, layered one behind another. The universe is enormous, and yet the portion we can observe is still limited. There may be regions of space whose light has not had enough time to reach us. They are not necessarily beyond existence. They are simply beyond our current observational horizon. That distinction is important. Science does not claim to know everything simply because we can see very far. Instead, it tells us where our knowledge ends, and perhaps there is something comforting about that. There is no requirement for you to understand the entire universe tonight. You do not need to hold 93 billion light years inside your imagination. You do not need to picture every galaxy. You only need to understand the direction of the journey. Earth is small, the solar system is larger, the Milky Way is vastly larger, the cosmic web is larger still, and the observable universe extends beyond our ability to intuitively imagine it. At first, this can make human existence seem almost absurdly insignificant. We are tiny, our lives are short, our planet is small, our star is ordinary. Our galaxy is only one among an enormous number. Against this background, it might be tempting to conclude that nothing about us matters. But physical size and meaning are not the same thing. A human thought is physically tiny. A memory has no measurable width. A moment of kindness cannot be weighed on a cosmic scale. A song does not become meaningless because the galaxy is large, and a life does not become worthless because the universe contains more stars than we can count. In fact, our smallness may be part of what makes our existence so remarkable. Earth is a tiny planet, yet on this tiny planet, chemistry became biology. Life became increasingly complex. Living creatures developed senses. Some developed nervous systems. Some developed brains capable of remembering the past and imagining the future. And eventually, on this small world, matter became organized enough to look into the night sky and ask what the universe is. We built telescopes, we sent spacecraft, we measured ancient light, we discovered that our galaxy is one among many, we discovered that the universe is expanding, and we discovered that even our own bodies contain atoms whose histories reach back through cosmic time. The carbon in your body, the oxygen you breathe, the calcium in your bones, many of the heavier elements that make life possible were created through earlier generations of stars. The universe did not simply provide a stage on which life appeared. The material of the universe became part of life. You are not separate from cosmic history. You are one small expression of it, and perhaps there is another thought worth carrying quietly into sleep. Somewhere in the enormous universe, there may be another planet. Perhaps it has an ocean beneath an atmosphere we have never seen. Perhaps it circles a star that has never appeared in any human telescope. Perhaps life exists there. Perhaps intelligence exists there. Perhaps, somewhere, another small world contains beings capable of looking outward and wondering whether they are alone. We do not know. And that uncertainty is not a failure. It is an invitation to wonder. Because the universe has already shown us how often our first impressions are incomplete. The moon looked close, it was far away. The solar system looked crowded, it was mostly empty. Pluto looked like the edge, it was another beginning. The Milky Way looked enormous, it was one galaxy among many. And perhaps the universe still contains discoveries that will change the way we understand our place within it. But for now, we can slowly come home. The galaxies become distant points. The Milky Way surrounds us. The solar system becomes a tiny neighborhood. The planets continue their silent paths. The sun continues to shine. The moon continues its journey around Earth. and beneath the night sky, our small planet continues turning. Perhaps you are still lying where you began. The room around you is quiet. Your breathing is slow. The universe has not become any smaller. It is still enormous, still dark, still filled with distances that the human mind can barely imagine. But perhaps you have discovered something else. Being small does not mean being meaningless. A tiny planet can hold an ocean. A tiny world can hold life. And a tiny mind can look outward and wonder about everything beyond itself. For a brief moment in the history of the universe, you are here, on this small world, under this enormous sky, breathing, listening, wondering. And perhaps that is enough. You do not need to carry the whole universe with you as you drift towards sleep. Let it remain out there. The galaxies can continue their slow journeys. The stars can continue shining across the darkness. The universe can continue expanding beyond the reach of our imagination. And you can simply rest here, on this small and beautiful world, beneath the same sky that has watched over countless generations before us. Good night.